to my channel. In this video, we are going to build a complete assumption-driven statistical workflow around the box plot, and we will generate a box plot using iris data, and we will gonna to test the normality using the Shapiro-Wilk test, visualize the distribution ggplot, and test the homogeneity of variance using Levene test. Apply Welch ANOVA with the variance of inequality and perform Games-Howell post-hoc test and annotate the statistical results directly on the plot, as you can see in this graph. So without wasting a time, let's jump in our R code here. So first we load the library, our tidyverse and ggplot2, and same time we are loading our data, iris data. I just run the code and we can see our iris data is here, and it have 150 observations and 5 variables. So on the variables we have a sepal length, sepal width, petal length, and petal width, and species as a term it have within 3 different species. So in this video we are going to check a sepal length. Sepal length exists in our first column, and we will check how the sepal length varies across the different species. For this we will prepare some visualization using a box plot. We are having here a ggplot. Our data is iris. On aesthetic we are using a species on the x-axis, y-axis our sepal length, and we are giving a fill or a color based on a species. And here we use geom boxplot as our geom, and outlier.shape NA, keeping all the values, is not excluding or clipping off any outlier. Alpha 0.6 to make dots a little transparency. And over the geom box we are using another geom, is a geom jitter, which we basically it giving us all the raw data points, and the width of the points are 0.2 and alpha is 0. And we use the theme classic here. So let's run the code and check how the box plot visualize our data. We run the code and we will see soon here our box plot. So now you can see here our box plots. So here in the box plots, the median and the horizontal black line is showing us in a median, and the box plot represents the interquartile range, and the whiskers are 1.5 times of the interquartile range. And as we can see, the medians are very different between all the 3 species, and geom jitter is also showing us data is very scattered, and as you can see here, at some points are really outliers also. So this is our simple observation, but still we don't know which species have a significant difference and which is really a significant. So to check this, we jump in our statistical parameters. So we check here normal test. For the normal test we are using here library rstatic. We gives our iris data, and we are grouping the data based on species, and we are using a very gold standard test for the normality called Shapiro test or Shapiro-Wilk test on a sepal length. And we run this code here. As we run the code, and we can see the results on our right side, and we see here all the species have a p-value greater than 0.05. So we can say here we do not reject the normality, like a null hypothesis is correct. However, statistical testing alone is insufficient. So we also visualize and inspect the distribution. How we do this? To check the distribution of a data, we do a ggplot, and ggplot we use here library ggpubr. We use the library ggpubr, and from library ggpubr is a function ggplot. Data is the iris. On the x-axis we are saying we need a sepal length faced by species. So let's run this code and we will see how the data is distributed. As we can see here on a ggplot, our data ggplot compares the sample quantile against the theoretical normal quantile, and we can see all the data points are laying around the diagonal line. When all the points are laying around the diagonal line indicates that distribution is approximately normal, and we can combine the visual inspection with the statistical testing. So as we can see, data is almost normally distributed, but here on the virginic some data is little bit away from the diagonal line. So let's see how the variance come when we check. So now we check the variance for this data. I will minimize this one here, and we comes to the next step. It's called analysis of variance. We are using a Levene test from the library rstatix. And here we have our numeric variable is the sepal length, and the categorical vector is the species, and data is array. So we just run the code here, and you can see down here output of a Levene test, and here the p-value is less than 0.05. As the p-value is less than 0.5, we say the variance differs significantly between groups. This violates a key assumption of classical one-way ANOVA. So here, when the p-value is less than 0.05, it's mean there is a variance between the groups. Visually, we see here Virginica have little bit difference, or data is away from that diagonal. So this group might be giving a variance. So now p-value is less than 0.05. So samples are normally distributed. They pass the assumption, but variance is not pass the assumption. So in this case, we are going to use a Welch ANOVA since the variance assumption is violated. So we apply a Welch ANOVA test, or also called a one-way ANOVA, and here we use one-way dot ANOVA test over a sepal length, tilde sign, species, data is arrays, and important thing is variance dot equal equals to false. When variance equals to all, it activates the Welch correction, and we run this code here and we get the one-way analysis of mean, not assuming equal variance. So here we can see the F statistics is like a 1.38, number of degree of freedom 2, denominator of degree of freedom is in a fraction 92.211, and p-value is really less than 0.5, assuming kind of 0. So Welch ANOVA here does not assume equal variance. Adjust the denominator degree of freedom, and it produces fractional degree of freedom values that we can see here, 92.211. So what it indicating when the p-value is less than 0.05, it indicating at least one group differs significantly. When this happens, we cannot directly apply the multiplicity test. So in this case, we are going to use Games-Howell Post-Hoc test, because Welch ANOVA tells us a difference exists, but not where, in which group is difference. So at this point, we are using a Games-Howell Post-Hoc test, and we are using library rstatix. We are using our data hours. Games-Howell test coming from rstatistic package, sepal length, tilde species. And when we are doing this, so we are calculating also a one new position at which point we are putting a significance. So we are making a using here function called mutate y equals position 7.3, a row number minus 1 into 7.5. You will see here, and we are saving this in the stat test as a, and we run this code and we get the whole statistical analysis here. So you can see sepal length in between setosa and vesiculara, setosa, virginica, vesicular, and virginica. And here the p adjusted values and p adjusted significance, like significance here, all three, and y position what we calculated is on a y-axis, which position these stars are coming, and this is giving us here statistical and output of this data. So we can say here, like between setosa and virginica, there are really a big significance of 2.86 into 10 to the power minus 10. So in overall, Games-Howell does not assume equal variance, does not assume equal sample size, and is appropriate follow-up to Welch ANOVA. So yeah, so like this we do a statistical test, and now prepare our box plot, and until here we use the same code. And here I used in the labs title, I gave like an sepal length across species, y-axis sepal length in the centimeter, and stat p-value manual. This is a function we are using from the rstatix library, and here we feed our statistical test what we calculated here, and labels we are giving a p adjust significant, this ones, because on a graph we want to show the stars. If we want to show a p value, we can give the labels as a p adjust, and the tip of the length is 0. Themes we are using a classic, and the size of the theme is a base size 14. And here in a theme function plot title, we are saying element text is you use the same as what we write it upper h, just bringing a center of the graph, and face equals to bold, like all the letters in a bold, and size is 16, and legend dot position is none, like we don't want any legend. So we just run this code here, and we will see our graph, and here is our beautiful publication ready. As we can see here, let me do a little bit here. Yeah, this is our plot. So I will just make it like this little bit, and this is our y-axis. Here we have a sepal length species. So we can see here within the Setosa and Virginica, there is a high significance, and the bar is at 8.05 here. And between Setosa and Versicolora, the value is 2.86, and the position of these stars are at 7.3. And between Setosa and third comparison is Versicolora and Virginica, and so between that we can see this y position is 8.8. And you can do the different kind of modifications using the theme function here. So overall, like this, we prepare our box plot using R, and we can make a really significant, check the significance using a different statistical function, normality, variance, and stat test. So this was all for this video. I hope you will like this video and you understand how to prepare the box plot and how to check the data distribution, normality, and variance. And if you like the video, please hit the like and subscribe button, and stay tuned for the next video. Thank you. Thanks for the watching.